In this demonstration, we are looking at the conservation of angular momentum, and notionally with a frying pan, but we're using for safety a table tennis bat to represent the frying pan. And the red side is indicating that the pan is hot, and the black side that it is cold, and the handle, of course, being made of an insulator, is cold. So if we have a pancake cooking in our frying pan, after a moment or two, we probably want to flip the pancake so as to cook the other side well. So when we flip it, we let it cook for another moment and then consume it and enjoy it. Now, having learned the skill of flipping the pancake, we might think that we could flip the pan, but we need to be careful. And as we flip it, we want to ensure that we catch it by the handle. Now, if we flip it in the manner that we flip the pancake, then one has to imagine that if it starts red side up and it flips, then catching it by the handle should ensure that the red side is still facing upwards. But is that what happens when we flip it? So we watch and see. And quite remarkably, it comes up black side. And of course, the reason is that somehow or another, in the act of flipping it this way, it has, of its own accord, done a rotation in a direction that we never intended. Now, this strange phenomenon is an example of the angular momentum being conserved in the movement. One doesn't have to do it with a frying pan or a table tennis bat. Any flat object, rectangular in shape, like a book, can demonstrate the same idea. Here you can see that the book is purple on this side, but white on the other. The writing is the right way up to read it, and the page is open to the right as you look at it, and the spine of the book is to the left. So if I toss the book in the manner that I tossed the table tennis bat, and we observe what happens. So as I flick it, lo and behold, it comes up white side, and the open pages are now to your left. So the rotation that I gave it was accompanied by a rotation in another direction, and all to ensure that angular momentum is conserved. Now, it's quite a tricky business to fully explain, but it's relatively straightforward to demonstrate. One could even demonstrate it with a mobile phone, but then a mobile phone, if it falls, could be easily damaged. Any flat object tested in this manner should work. It's worth stressing that the orientation matters. If I were to toss it this way round, the rotation about the long axis this way is different from the rotation about the shorter axis this way. And about the shorter axis exhibits this relatively strange behavior, about the long axis would not. Conservation of angular momentum in a novelty.